thanks to Marino for getting at the CNCF KubeCon last 2 weeks ago. And again, make sure to fill out that survey. So for the main event, we have Christine Kim giving us a CNCF wrap out. We have From CloudEvents to Cloud SQL by Calum. We have Scaling Kubernetes, Mastering Autoscaling with Cluster Autoscaler, HPA, VPA, and KEDA by Sathish. I had to look up all those acronyms before. I wasn't going to say the whole title. And then we have Falcoctl is to Falco as KubeCtl is to Kubernetes by Curtis, and How to Control Kubernetes Costs by Rajith to finish it up. And like I said, it's brought to you by the CNCF meetup organizers. Archie, Jason couldn't make it. Marino, myself, Andre are here. Next quarter when we run it, you're going to see probably their faces and not us, but really appreciate all of the help the organizers put in. You can follow our link tree for updates. Again, we always keep it updated. Hopefully you guys didn't mind my email spam. I sent out like 3 or 4 notifications, hoping you guys signed up and came. And that's what it's for. So you register, you get to find out when we're having our next meetup, and like I said, you can stay updated. Want to give a special shout out to our sponsors. We have a gold and silver sponsor, so Sysdig and Grafana Labs. All of their help helps us put on these events, so really appreciate it. And Arctic as well as a silver sponsor. If you guys were here earlier this year, we got the Arctic office. And then again, we want to give a special shout out to Ada. And Andre has a few slides to go through, but again, really want to say thank you for having us into your office. It's a beautiful space. And yeah, I'll hand it off to Andre.
Thank you, Michael. How many people here have heard of Ada before? All right, quite a number. All right, so this is just me doing my thing. So Ada is one of those AI. Our goal is to automate customer service 100% with AI. And maybe you've seen some demos out there, some good presentations. We actually are live in production with 130 plus live agents. Maybe you've used them. Voice, email, messaging, 2 million conversations a month and growing on generative AI. Maybe some of these customers, you've seen them, and this is what we do. So we've been around for 6 years. We pivoted with Gen AI, and we've grown our product hugely. Maybe some people you hear use Well-Simple. That's us. Maybe sometime you called somewhere. It was also us. Maybe use Canva. So this is just some of our customers using generative AI live in production. So we are one of the hot startups, but we were doing it before it was hot. And we are hiring. I will let you take a picture of this. All right. Also, all that fantastic pizza, drinks, and the space was sponsored by Doppler. How many people here use Doppler or have heard of it? I see a few hands. Oh, you're in for a treat. We use Doppler at Ada. It solves all our secret management problems, and we love it. But so they were supposed to be in here in person, but it's Thanksgiving in the US, so they just sent us a message to play. But if you want to see Doppler a demo later on, just come up to me. I'll show you why we love it so much. But yeah, here's a quick message from Doppler. You sign in with video? Oh, we have to share with audio. Did I just exit? Oh, technical. I think I left the meeting. Oh no, here it is. Here we go. Share with audio.
Yeah, you get up.
Share sound.
And we're back.
It's such a pleasure to be part of this event today. My name is Chandler Mayo, and I'm a Senior Developer Advocate at Doppler. First off, I want to express how excited we are to be part of this incredible event here in Toronto. It's always amazing to connect with the vibrant DevOps communities that drive innovation and set the standard for resilience and creativity. A big thank you to the organizers and everyone here for making this event possible. For those who don't know, Doppler is all about simplifying and securing your secrets management. We're here to help DevOps teams, developers, and SREs take the complexity out of handling sensitive data while maintaining the highest levels of security and collaboration. Whether it's for development environments or production pipelines, Doppler is designed to integrate into your workflows, allowing you to focus on building, scaling, and innovating with confidence. Now, let's talk about some of the real challenges we're tackling in the DevOps space. Have you ever dealt with secret sprawl? Things like API keys, certificates, or database credentials scattered across systems, repos, or even sticky notes? It's a common issue, and it can escalate quickly. Secret sprawl not only creates security vulnerabilities, but also makes troubleshooting and scaling unnecessarily difficult. And then there's the challenge of managing sensitive data across multiple environments. From development, staging, production, all of these environments have different configurations, which can create bottlenecks and lead to inefficiencies. Add to that the balancing act of maintaining team collaboration while ensuring airtight security, and it's no surprise that many teams feel stretched thin. This is where Doppler comes in. We've built a platform that centralizes your secrets management, making it easier than ever to handle sensitive data across your organization. With Doppler, you can securely store, sync, and manage secrets across all of your environments. Our platform integrates with your existing workflows and tools while offering granular access controls, and it ensures everything stays in sync in real time. The result? Reduced complexity, stronger security, and a more efficient way of working. One that lets you get back to focusing on what matters most, delivering value. So, why does secrets management matter so much today? That answer lies in the increasing demands placed on DevOps teams and engineers. Security expectations are higher than ever, and there's a rise in data breaches and stricter compliance requirements, which just leaves little to no room for error. Mismanaged secrets aren't just a security risk. They can lead to outages, vulnerabilities, and productivity roadblocks that cost time and real money. But this isn't just about avoiding worst-case scenarios. Secrets management also drives efficiency and reliability. By automating how sensitive data is handled, Doppler helps teams deploy faster. Doppler helps teams reduce human error and prevent costly mistakes. Whether you're scaling a startup, or managing a complex enterprise, or working to just streamline daily operations, a strong approach to secrets management is a game changer. Before I wrap up, if you have any questions or want to see Doppler in action, our wonderful hosts at ADA will be demoing Doppler and answering questions on our behalf. Our team is celebrating Thanksgiving in the United States. Be sure to check out how Doppler can make a difference in your workflows. Thank you to CNCF, our amazing hosts at ADA, and every single one of you for your time and interest. Let's keep building incredible things together. Enjoy the rest of the event. Thank you.
All right. Thanks to Doppler. It's not quite a turkey feast, but he did send us pizza, so really appreciate them making a Canadian Thanksgiving, I guess, soft one. Again, if you have any more questions, Andre and the ADA team will be happy to help.
Hello, everyone. It's such a pleasure.
All right. Yeah, there's a little QR code. Like I said, I'm going to be sending the slides out as well, so if you have any questions, feel free to follow up with them. There's just two small CNCF announcements that are coming up, and then I'm going to hand it off to Christine, and that is KubeCon India. The first ever KubeCon in India is going on in December, so there will be some announcements. It's pretty cool. I think they're doing like a KubeCon and Linux Foundation open source summit all in one, which is pretty awesome. But the big announcement is KubeCon EU, KubeCon London. The CFP is closed. However, the co-located CFP is still open. So if you're looking to harass your boss into trying to pay for a trip to London, I recommend trying to get that CFP in. Again, co-located event, they're all specialties. There's AI, there's security, kind of, and backstage, things like that. So something for everybody. CFP closes, or CFP notifications will come out in January. And then, of course, yeah, it's London. Why not? Try to get a free trip. The last thing I want to say is there's an end user survey. So if you're using Kubernetes, Prometheus, any of the CNCF specific applications in their foundation, they want some feedback. So if you get a chance, it's like 7 questions. They're just looking to figure out how to balance the budget next year. All right. And on to KubeCon 2024 with Christine Kim. Welcome.
All right, thanks so much. So yeah, I was at KubeCon in Salt Lake City, which was a couple of weeks ago. And If you haven't been to Salt Lake City, it is a beautiful area. It had the Olympics, which was really nice, but a lot of the metrics came out recently, so it was roughly 9,000 attendees, and it always surprises me, but it's always roughly half of the attendees are first timers, so you get to see a lot of people who are new, and I always am at this open source pavilion booths, and I'm with the Cilium team, so I always get questions like, what's a CNI? I'm like, are you running Kubernetes? So it's like fun, yeah. There was a lot of CFP submissions, and then the acceptance rate was 11%. So we saw that in London, they actually had maybe like 2,000 CFPs submitted. So the co-located days are really important if you do want to go. And I personally find that the conversations there that you have in the hallways are much more valuable. And it was Kubernetes' 10th birthday too this year. So here's some hot topics that were around that I saw. So first off, AI is shoehorned into everything, but there's a lot of projects that are working around how to optimize batch workloads. So for example, Q, it works with optimizing how your servers are distributed and also who has priority over different events. So if you're curious about how to schedule your batch load projects, a lot of other things are operating around LLMs. So personally, I'm a contributor to the gateway APIs under SID network. And we have a cool project that deals with how to route LLM workloads to your ingress or your gateway. Another topic that was interesting was platform engineering. Of course, trying to make the lives of developers easier. So backstage is still a hot topic around Spotify, and you can see a lot more sponsorship and engagement around it. Another thing that was kind of cool was the ecosystem and how to go green and be cost efficient with your workloads, because obviously running AI takes a lot of energy out. So how do you balance that and mitigate that? So there's some side projects there, Kepler, Cube Green, which are projects I haven't seen before, but could be interesting if you're into saving the earth. And lastly, always, security is a cool topic, defense in depth, automation policies. I'm biased because Cilium is a CNI at its core, and so we have really strong network policies, and I do like that. Some project graduations, Dapper and Cert Manager are officially graduated, so that's really exciting. Day zero co-located events are always a really fun topic. And it's always interesting because the North American ones are different from the EU ones. So I know in EU, they have telco, for example, because there's a lot of telco companies there. So that's always interesting. But at the co-located events here, we had Cilium, eBPF Day, we had Istio Day, Linkerd as well, I think maybe had one. Envoy as well. And if all the recordings are on YouTube too. So if you weren't able to go, you can always watch them at your own leisure. Gateway API, shameless plug, I love the Gateway API project. I contribute to it, and there's a lot of interesting and upcoming events within it because it's one of the faster sides of the Kubernetes project because it's not deployed with the core Kubernetes, it's on its own release cycle. Multi-cluster was also another interesting topic where people are now running more distributed systems across different cloud providers, and how do you do that? And we've actually seen a large shift towards people self-hosting on bare metal. So going to the cloud providers, realizing how expensive it is, and then coming back and then deciding to put the investment into their own cluster and how to run that at scale across the world. And so also there's a Cilium project report that was published. So they always do this at CNCF events where they publish the health of a project and how much growth it's reached after it's graduated or incubated. So Cilium was graduated last year and they published the report on that. Some new CNCF donations, Podman, Builda, and Scopio, Podman Desktop, and Bootsy. And there's a lot of cool new certifications as well. So if you are passionate about any of these, they're pretty cool. I think the Backstage Associate would be really interesting, especially with the platform engineering tie over. Here are some links. They're going to be sent out, so no need to fret about taking pictures. But Architecture CNCF IO, that's a new one where the CNCF is trying to bring more coherence around different projects and how you can use them together, best practices. And then lastly, next year in Atlanta, Georgia, we have KubeCon NA there. So for your calendars, block it out. get your CFPs ready. All right, thanks.
Awesome. Thank you, Christine. Appreciate it. Yeah, works. All right. First up, we got Calum talking about SQL. Well, I won't give it away. You get up here and talk.
All right. All right, looks like the slides are working. So today I want to talk about the CloudEvents project as well as CloudEvents SQL. For people who aren't aware, CloudEvents is one of the more recently graduated projects. It graduated last January, I want to say. It's been around for a while, and the newest project they have in the community, which has been released, is CloudEvents SQL. So today I want to give a quick overview of what is CloudEvents, why might you want to use it in your system, and then how does CloudEvents SQL fit into everything. So to start with CloudEvents, I like to think of an analogy of connecting devices to my computer. It's a common task, and it's really easy if my computer has the right ports for whatever I want to plug into it. But a lot of times I get some kind of cable that just doesn't fit into my computer, and now I need to buy some kind of adapter. And a lot of what we're doing as developers is actually just making these adapters and connecting different pieces of our systems together. And that's a lot of effort that maybe we don't want to have to do every time. And CloudEvents is basically trying to solve this problem for how do you integrate and communicate between all of the different systems you're running in the cloud or on premises. So maybe I have some service and I want to send just hello world, but I need to send it into Kafka. And maybe that service is actually getting this data, but it's in MQTT. These are two different protocols. Now I need to write something in the middle that translates these. And that's not particularly hard, but it gets repetitive and it gets complicated when I have a lot of different protocols. And so what we'll often see in a lot of applications is we have some kind of code that's sending out an event or a request or some data. And in green on the left, we have the business logic. And then we have some custom glue, which just binds that into a protocol. And then we call the protocol library that communicates our data. And then on the other side, again, we've got the protocol library. And then we have some custom glue that translates that into types that our app understands. And then we have our business logic. And this gets really complicated once we have a whole bunch of different data sources and data destination syncs that all speak in different languages. And if I want to add some middleware in the middle, it's almost impossible to write that efficiently to be able to get anything for filtering or routing or anything, because there's so many different formats it needs to speak. Or even if I just want to connect this myself, that's just a lot of engineering work to keep track of how everything should communicate. So CloudEvents came out and they said, we want to describe the metadata about everything we're sending in a consistent way so that I can send data. I don't need to worry about what protocol it is, and I'm always going to know what metadata I have and how to access it. And so instead of this picture where I have this custom glue every time between my logic and the protocol, I just have the CloudEvents library every time. So now my code just needs to be able to talk to CloudEvents, and then I can pick whatever protocol and send it into it. So for example, in Go, I might write, it's a little small on the slides, a handle function which takes in a Cloud event and returns out a Cloud event or an error. And then how I receive the Cloud events is up to me, and I can pick whatever protocol I want. Or in Java, I might have a method on a class that takes in a Cloud event as well. And here's an example, some code in Go where you can basically send Cloud events on HTTP or receive it in NATS. The details isn't specific, but the cool thing is I can pick NATS or MQTT or Kafka or HTTP or any other protocol and bind my data into these protocols the same way every time and get it how I want. And I have complete control over the underlying protocol. Cloud Events doesn't care how I configure Kafka or NATS. I just get my data consistently always. So in this picture, it's actually really easy to do that complex routing or middleware since it's all just Cloud Events in the middle on some protocol. And I can take my system and put it on top of some other protocol, and as far as all of my different components are concerned, nothing changed since they're just talking Cloud Events. And the way Cloud Events does this is it basically gives you this set of context attributes that describe the metadata. And they say you need to have at least 4 of them. First one's the spec version. That's just which Cloud Event specification you're using. Then there's an ID for the event, which has to be unique to the system. The source, so where did the event come from, and the type. And then outside of that, you can have any number of your own extension attributes that describe whatever it is you want. And they can be string values, booleans, integers, timestamps. I think there's a couple other types they can be as well. But you can basically just keep adding whatever other metadata you need, and CloudEvents is able to figure it out and handle it. And so CloudEvents defines these attributes, and then it also defines how you connect them to the different protocols. And it says you can either do it in a binary way or a structured way. And the binary way just means that the attributes are headers in the underlying protocol normally. And the structured way means we're going to make a big JSON document, and that's actually the data we're sending. And that JSON document is going to have all of my Cloud Event attributes as well as the data as a key. So if you look at it, on the left, we have binary HTTP, and we can see those different Cloud Event attributes are just HTTP headers, prefixed with CE- to make sure that we know it's a Cloud Events header. And on the right, we have structured HTTP, and it all ends up in the JSON document. What's cool about this is if your app speaks Cloud Events, you can just, speaks HTTP, you can just add 4 headers, and you get Cloud Events for free. You don't even need to use the Cloud Events libraries to do that. You can just set 4 headers. Similarly, if I wanted to use Kafka, I can add a couple headers. Sorry for the small font. And I get my Kafka message now is a Cloud Event as well as whatever I was sending into Kafka already without changing any of the data. Or I can choose to use the structured format. My personal advice is use the binary format wherever you can. You get much better compatibility with other systems. But some places require structured. For example, AWS EventBridge says, hey, you need to send structured Cloud Events if you want to send us Cloud Events. If you're using the Cloud Events library, that's really easy. You just pick, hey, I want structured or I want binary, and it converts it for you. But in general, you can get binary Cloud Events without ever touching the Cloud Events SDKs if you want to. So one of the questions the Cloud Events community is wondering is, if we have these common metadata across all of the data we're sending, can we query these different packets, these different messages consistently? Can we filter them? Can we ask this consistently? And the idea was yes. In June 2024, CloudEvents released CloudEvents SQL version 1. And it's a programming language that basically lets you compute values and match different attributes from your Cloud Events. And it tries to borrow the syntax from SQL where clauses. That's where the SQL part of Cloud Events comes from. But it's not directly one-to-one SQL. It's more inspired by. So if I wanted to access an attribute, I could just type the name of the attribute. If I want the ID of the event, I just write ID, and Cloud Events SQL gives me the ID of the event. If I want to check if one of those optional attributes exists, there's the exists keyword. And so if there's a subject attribute for an event, exists subject would give me true. You can also do equality. You can do Boolean operations. You can do nested expressions, basically anything you'd expect from a relatively simple programming language. You can do wildcard string matching with the same syntax that you'd expect from SQL. And there's also built-in functions. For example, you can check the length of a string. You can concatenate strings. You can take the left 5 characters of a string. There's a lot more. There's 20 or 30. I just picked some. And you can add your own function calls. If none of these work for your use case, you can define your own function and add it. One thing to note there is that you'd have to use one of the CloudEvents SQL SDKs, which are in Go or Java. So you can't pick any language to write your custom functions in. But once you've written it, it should just work. So the main use case we've seen for this so far is for event filtering. You can write an expression that says what events you want, and if it evaluates to true, then the event goes to the destination. And this was initially implemented into Knative eventing, and it's fully supported there in GA as well. And CloudEvents SQL is actually a collaboration between the Knative community and the CloudEvents community. And so for event filtering, what you do is on a Knative trigger, you set filters and you write CSQL, and you can write whatever expression you want, and that gets evaluated against every event. And if it evaluates to true, then it gets delivered to the subscriber of the trigger. And so at this point, I'm going to hop over to a hopefully working live demo, and we'll see how it all works. So on the right terminal, this is going to log out any Cloud Events we get. And on the left terminal is just so that I can type. So if I edit the trigger we have, we can see that currently it's got a CSQL expression that just is false, so we aren't getting anything. If I switch that to be true, then hopefully, sorry, I'm trying to do this with one hand, and I forget typing with one hand. Hopefully now we should start getting some events on the right. And so we start getting events, one every second. They've got kind of randomly generated events. So I can start now making more interesting queries. So maybe what I want is I care about the type, and I want to see anything that was a success. So I could say type like, and then I can do success using that wildcard matching that I was talking about before. And then I can write that. We give it a second to update, and then we're going to start to only get success events instead of failures. And now some failures are happening, so then now we're getting success again. So it's really easy for me to just pick whichever ones I want. And I can also make more complicated expressions. So maybe I want it either to be success or source is equal to my HTTPS localhost. Hopefully there's no typos. I think I am missing a quote here. And now over here, we should start seeing some failures as well that have localhost, if that all worked. So success, 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 yeah, failure, and we got localhost now. So I can really easily write very complex queries using everything I know from writing SQL, but now it's my data in the cloud. And here we're using it for filtering. If for some reason I just wanted to consistently access some of the metadata about my events as a value, I could have, instead of getting some Boolean expression for filtering, computed something, maybe using those like integer extensions and doing some math for some reason. So that's the demo. That's the basics of CloudEvents and CloudEvents SQL. There's a couple minutes for questions. If anyone has questions, just raise your hand and I'm happy to answer. Over there.
Hold on, I'm coming.
Okay, we have another
I
microphone.
think he was going to jump into questions so quickly. First off, thanks, Calum. Great demo. The one-handed demo wizard. Very impressive. Can't even type with two hands. All right, here you go.
Is that SQL language the only language you can query those event information?
It's the only one that CloudEvents as a community supports. They're just headers, and there's SDKs for everything, so you can access the metadata yourself with the SDKs. The big reasoning for this query language is it's programming language independent, and so it doesn't rely on Go or Java or whatever your service is written in. It's just its own thing.
So how's the integration of it with the observability tools? Is that you still have to like?
We don't have any integrations with like observability tools right now. Okay. It's pretty new. If you have thoughts on that, feel free to open a GitHub issue, but it's pretty new and we're hoping people use it and give us feedback.
Okay, thank you.
We got time for two more questions. All right, I saw the two hands go up. Good timing.
I know, thanks. Great presentation, Calum. Pardon my ignorance because it's my first time with CloudEvents, but is there a scope for a CLI tool where we can use the CLI to query and use CloudEvents SQL instead of kind of putting it in a manifest? Because even from a GitOps perspective, right now, just in demo, you put it in a manifest, right? But in a more interactive fashion against the events that I'm getting, if there's a CLI tool that I can use.
Not currently. You could use the Knative CLI to do that. So CloudEvents and CloudEvents SQL are kind of independent from however the events are being delivered. I was using Knative eventing just so I could send events because Knative eventing has CloudEvents SQL embedded in it. CloudEvents SQL as its own thing is just an expression language which evaluates against a single event. So you could build your own thing. Currently, the only system that I know of, at least it's open source, that supports the SQL and actually has events flowing through it is Knative, which is why I was modifying Knative.
Got it. Okay, thanks.
All right, we only have time for one more, but you could get them at the break when you're eating pizza.
Thanks for the presentation. In follow-up of the first question about observability tools, was there any thought to be inspired by PromQL tied to the timing of events and whatever other numerical attributes that may be in either the data or the metadata?
So that's one of the things we're looking at for 1.1. There's timestamp data in CloudEvents, and it was decided that it was autoscope for version 1, but version 1.1, there's interest in looking at the timestamp values and how to handle them. One of the things which people haven't really discussed so far is how to write queries across a time range. So far, the idea is it's just to be applied against a single event and see what happens. It would be interesting to look at how you can extend that to look at events over a range of time, but so far, no one's looked into that.
Thanks.
All right, thank you, Calum. Appreciate it.
Thank you.
Next up, we got Sathish talking about everything auto-scaling in Kubernetes. Time for that question now. Hold on, you might as well ask your question. He's got 2 minutes to set up.
So Calum, yeah, this is a pretty easy one. Awesome real world problems that you're solving here. I'm just kind of curious in terms of performance, right? When we're looking at the structured approach, there's going to be more data going over the wire. Are you seeing any time performance slowdowns when using the binary method or structured?
So binary is normally going to be faster is the answer. Knative, as an example, you send CloudEvents into the system and then it does a whole bunch of internal stuff and sends them back out. Even if you send Knative structured events, we make them binary internally because it's going to be a lot faster. I don't have numbers off the top of my head. A lot of these things are pretty fast since it's a single request. So for example, most of those CloudEvents SQL expressions, even the like matches, we did benchmark those quite heavily, and like matching on strings is in the ballpark of 40 to 50 nanoseconds for a single match. So it's not a very expensive operation, but these things are used in the context of really high throughput, so you don't want it to be slow. It's a little bit slower for structure. It's more the total volume of data in the network that changes things.
Perfect, thank you.
Yeah.
Another question?
Oh, okay. We got time. We got a Zoom download going, so might as well just keep the questions coming.
Hi, I'm curious. You said the SQL queries supports both Java and Go. So do you have 2 copies of the SQL query logic written in both languages?
Sort of. It's implemented using something called Antler. I don't know if anyone's heard of Antler before. Antler is an open source tool that basically generates parsers for a language from a set of grammar rules. So all of the parsing is automatically generated to whatever language you care about, and then the actual logic of how to do matching or and or was implemented twice in Java and Go. Those 2 were done first because those are the 2 SDKs that the Knative community needed. If there was interest in it in any of the other CloudEvents SDKs, then it'd be pretty straightforward to implement there as well. But so far, no issues have been open, so we're just leaving it at Go and Java.
Yeah, thanks.
All right. Oh, I think you made it. Any other questions?
Yeah, it's on the slides. I forgot to tab to that. Yeah. So
I'll send it all out. Check your email tomorrow. I will be spamming you guys. You got it. We're all good? Oh, yeah, look at that. There's Calum. Thank you again, Calum. Appreciate it. I know the Zoom thing, it catches everybody off guard. It's way better than the HDMI cable, though. Okay. Hey, welcome, Sathish. Hopefully you don't have to type.
Showing the Zoom. Okay, I just installed it. So he needs to be yeah. Yes. You need to let me in again.
I would have intermission music, but ooh, brand new laptop. That M4? Ooh. It's an AI demonstration? Hey, there we go. Company meeting.
Say hi everyone. Good evening. Sorry for the delay. My name is Sathish Kumar Venkatesan. I work for RBC, and like I'm a founder for DevOps Cloud Junction. So this is like a e-learning website. We just built it recently. It's my dream, like 5 years dream. Basically, like we wanted to share the information, whatever we know today. And then I'm a KubeCon nerd. I recently got my jacket in the CNCF KubeCon North America. And I'm a GitHub certified and I'm a Backstage certified as well. Yeah, I'm a cloud native enthusiast. Like if you want to talk about anything on Linux, DevOps, cloud engineering, AI, that's the next thing I'm focusing on. So yeah, anything about technology, I'm happy to share. And then like interested on photography and then videography, and then anything with the gadgets. I have a lot of gadgets in my home. So yeah. Today, my topic is about autoscaling. So these are things we are trying to focus on right now today. It's about cluster autoscaler, horizontal, vertical part autoscaler. And then the last one is like a hot topic today. Like it's like Kubernetes event-driven autoscaling. It's just called as KEDA. So how many people are using Kubernetes here? Okay. Okay. And then how many people are in using any of the managed Kubernetes? How many people are using OpenShift? Yeah, Michael definitely has to say because he's working for Red Hat. Okay. So let's go over like why we need autoscaling. So because like we have like a large number of workloads we deploy every day, and then like, we need to manage efficiently, right? So people started using Kubernetes just by Docker containers, not people were able to like schedule large number of workloads or like manage the orchestration, right? Like basically like I want to manage that many number of workloads, and then like I cannot manually trigger like Docker run and create multiple containers or so. That's why people thought, maybe Kelsey and other people who were on Google, they were thinking, okay, this is not sustainable. And then they, okay, let's build one orchestrating layer. And then that's how Kubernetes is born, right? So it's already 10 years in Kubernetes. And then like in this room, we can see like only maybe 5% of the people are, or maybe 10, 20% of the people are using Kubernetes. And the people who are using Kubernetes, it's not like efficiently they are using. So people just using it for the namesake, like we wanted to use Kubernetes, but really doesn't know like how to use Kubernetes. So what I'm trying to say here is like a lot of room is there for us to like improve the efficiency or like cut down the resources, right? Because like you have a big cluster and then you may be just running for 10, 20% of the workloads. A lot of them are like going waste. So try to cut down the waste, try to cut down the carbon emission, make it eco-friendly. So whatever you can do your part at your work, try to do it. So that's what I'm here. I'm trying to showcase like what are the things you can do to make like how you can run your Kubernetes cluster efficiently. So cluster autoscaler. So that's like a open source project as well. And then like many of the managed providers has its own flavor of cluster autoscaler. So basically the thing is like you have a large number of workloads, or let's say like you are creating a, for example, a small Nginx web server deployment or whatever, right? Or a Redis deployment. So you are creating that many number of replicas, let's say, and then your underlying resources on the node doesn't have that capacity. So the providers, the underlying orchestrating layer, right? It just goes and creates that many number of instances. So you say like, okay, I want my min node to be 1 and then like max node to be 10. So based on your utilization or based on your need, it dynamically provisions those nodes. Nodes in the sense it's just a virtual machine behind the scene. And then it orchestrates that particular workloads to be going on scheduling in that particular node. And then like if your utilization is reduced, obviously it's going to cut down the node. Like it's going to delete that node and then like it's going to like optimal, right? So like let's say like you need 5 nodes today, like say, tomorrow is a big day, right? So it's going to be a Thanksgiving day and then it's a Black Friday in the US. So let's say like you are running your workloads and then like you didn't do like a cluster autoscaler. It's very like if you're doing manual scaling, it's not going to help you because you need to wake up in the night and then you need to manually scale it. So think about those things, like these are things you can do, which you can enable it, and then like by which you can dictate what should be the ideal state or what should be the target state. Based on that, this cluster autoscaler monitor the resources, and then based on like, let's say like you have a number of like lot of parts pending, it goes and creates a number of nodes. And then like, okay, those parts get deleted or like you don't need those things. So once those parts are deleted, it keeps watching the resources. And then like if this is okay, I don't need this many nodes, let me go and delete it. So it just goes and behind the scene, it goes and deletes it. These many things like we will be like in maybe 10 years back, we were doing manually. Even like 5 years back, people are doing it manually. I'm not sure like today, even some people may be doing manually, like deletion and creation of resources. So cluster autoscaler can do it for you. Begin the scene, like you just need to provision the right resources and then like target the nodes, like how much exact nodes you need and so on. So based on that, you can customize it. You can say like 50% of the workloads are there. You can still create the nodes. So you should be able to like spin up the new nodes. You can customize it. Sometimes managed providers, they manage it, but still you have an option to like go and customize further. Next part is horizontal part autoscaler. So the horizontal part autoscaler is, for example, like you have, let's say same thing, right? So you have a big massive application and then like you don't know like how it's going to burst. Same thing, like for tomorrow's big day, we don't know like how it's going to burst. And then like you want to, previous one, what we saw is like node scaling. This one is like pod scaling, like your application, you have a single application, a microservice, whatever. You want to scale it dynamically, like based on the resource utilization or whatever. So what it does is it just checks your CPU and memory metrics, like CPU and memory utilization. Based on that, it's going to dynamically scale the replicas. So you can dictate. In this example, I was saying like I have just a Apache PHP application, whatever, and then I'm saying like min replica is 1, and then max replica is 10, and then average utilization should be 50. So when it goes more than 50% of CPU resources, it's going to scale. right? Max it can go to 10, and then like if their CPU average utilization comes down less than 250, it's going to reduce the replicas. So this is about horizontal part autoscaler. So I'll describe the same thing there. So scale up and scale down. So based on that events or based on the resources, it's going to resource limits or request metrics basically. So it's going to scale up and scale down. Then is what's vertical part autoscaler. There could be a lot of situations where you can't run multiple replicas, right? There could be some scenarios where you need to have like a single instance of your application to be running. That's when you make use of VPA, which is vertical part autoscaler, so that like you can bump up the CPU or memory for that single instance to how much ever you can. So you can think about it like it's like a big giant server. You can like a building like a 12 core, 20 core, 30 core VM, and then like maybe let's say 400 GPU, 400 GB memory or whatever, right? So you can increase your CPU and memory within that single instance or single replica. So it all depends on your use case. Some application may or may not support multiple replicas. So that's when you go and look for a VPA. So HP and VPA cannot work together. You have to do either HP or VPA. And then the interesting part, fun part is KEDA. So people thought, okay, CPU and memory and custom metrics is not very sufficient. I need more privilege. I need to decide based on my external metrics or external resources, I should dictate what my application should be, like how my application should be running. So this is an interesting project. And then it's a graduated project as well in the CNCF. So the way it does, the way it does is, it basically checks your external metrics. For example, I listed the event sources, some of the event sources. They have like 75 scalars, so by which you can use that scalars and then like you can dictate how your application should react, like how many replicas should spin up, or like beauty here is HPA, VPA, at least minimum one should be running. Here, it can bring down to 0, and then it can go up to whatever number you dictate. It can go down to 0 in the weekend, and then maybe you can bring it to like a 10 or something in Monday morning, whatever. So by which you are cutting down your 2 days workloads, like a two days, like times whatever number of hours billing from your cloud providers. That's a huge saving actually. I'm not sure like how many people are doing those things, but it's good to do. The main thing here is, for example, I will say like, okay, I have a Kafka server, right? A Kafka application, and then like there are some messages not being consumed, or I'm getting more number of messages, so I can dictate, okay, I'm getting large number of requests and large number of messages in my Kafka brokers, and then like not many people are there to consume, by which I can say, okay, this consumer group is receiving a lot of messages, so by which I want to increase my other consumer applications to scale up to maybe 10 or 20 or 30 or whatever. So by which like it is easily able to consume all those messages, and then like subsequently whatever transaction or whatever it has to do, it will be able to do it. So yeah, same thing as database as well. So you can dictate, for example, somebody trying to persist some number of connections or something in your database. So I can say, okay, my database connection is 100, by which I want to say, okay, I have 100 connections, but I have one single application running, and then it's choking somehow. But you're not able to see it, like CPU memory is not throttling, but still it's not behaving as expected. So based on your external resource, you can go and dictate how your application should be running, like how efficient it should be running. So you can increase it like, let's say like 5 replicas or 10 replicas or whatever you want. So those are the capabilities. So yeah, it's a fun time. Let's see.
Can you do it with one hand?
Yeah,
Do you need help?
Yeah. I can.
Let me know. I'll come hold the microphone for you.
No, it's okay. I can. Sorry about that. Oh, thanks. we should have done it before. So it's not showing. In the screen.
You zoom in just one more time. Perfect. Thank you.
Okay, so what I've done here is I just created a sample deployment, which is just like a dummy app. So let me show you this. Yeah, it's just a simple Nginx deployment. And then, so the scale object looks like this. This is a, sorry. So this is my scaled object. And then the way it looks like it is, I have a scaled object. And then I'm just saying like, okay, minimum is 1 replica and then max is 10 replica. And then this is my time zone. So I'm using a cron scaler right now. So I'm dictating, okay, this time, like start time, it's like 6, like I can change it now, 7:05 to 7:08. Bring up my parts to like 10 and then like maybe like 7:10. Go back to like 0 replicas. You can do whatever you want. So this is just one example. Remaining like this is one of the scalar I was talking about, like similar like that. You have 70 scalars. So I'll just quickly change it and then show you. So what's the time? It's 19:06. 27. Sorry, I'm not running nose as well. Sorry. There may be 10, whatever. So what it's going to do is, I think I should have sorry. Let me show you how many parts I'm running right now. So I just running what right. It's just 1 replica running right now. Let's see them. What's going to happen now? So I just reconfigured it. So what I'm trying to say is start at 7:07 and then increase it to like 10 replicas, decide it's like 5 replicas you should match with, and then like bring down my replicas by 7:10 because we don't have sufficient time. That's why I'm trying to do this. Let's see what's going to happen here. So it's already did it actually. So if you see that first part, it's like 57 minutes. The cron job consumer, that's the app I'm targeting. So it's going to scale up and then like bring up new parts. So this is like just a cron scaler. Like say like you have a batch job and then you want to process it so quickly. So instead of you waiting for it, you can dictate saying, okay, automatically do this. Maybe you end day last, like end of the day batch. You can just say, okay, bring up like 10, 20 parts, consume all the messages, do whatever batch processing, and then like kill it or whatever. You don't have to deploy that many number of pods manually going there in the night at 12 a.m. or whatever. You can just schedule it and then it should be similar. Like you can do a lot more. You can use like a Redis keys or whatever. So you can say, okay, when my Redis keys length increases to certain length space, then you can scale it, scale the number of replicas. So there are like many scalers. So try to take a look and then is it. So we have like 71 scalers today. So go and read more about those, and then there is something called HTTP add-on as well. So basically, like you can increase the number of, like based on number of requests, I can now increase the number of replicas. So let's say for Black Friday or whatever, I know like it's going to be a heavy traffic. So based on the number of requests I'm getting for my application, I can scale up and then scale down. So yeah, one last thing. I think I'm done. Any questions so far? Maybe I was rushing too much actually, I think. Yeah, any Q&A.
Okay, well, are you on questions now? One-handed and on a new laptop. Okay.
There is one.
Oh yeah, you picked. I was gonna say, don't pick the guy furthest away from me. Go on over.
For the queue-based scalers, what is it actually looking at when it's making the scaling decision?
The KEDA one?
Like the queue, like if it's looking at like Kafka or ActiveMQ, what's it scaling based on?
So basically, you just provide that resources. So because it knows to connect to the Kafka broker, you pass authentication and everything. So it goes and gets those data from that Kafka broker itself. Like,
okay, so like looking
it's
at
basically
like
running a client or something to get that information from the Kafka broker. Based on like there are like certain scalar examples you will have to go through and then try to do it actually. So it is Kafka. So there's RabbitMQ.
It would be like a manifest.
Yeah, for
right?
some example,
Yeah.
RabbitMQ, right? So you just connect to the RabbitMQTT broker, and then you pass the credentials, and then based on the queue length or whatever, you can decide like what's the number of replicas you can increase and so on.
okay, queue length, gotcha.
Yeah,
Thanks.
it's basically connecting to the actual source, that target environment, and then like trying to get that metadata from it or metrics from it, and then by which it dictates like how your application should react to it.
Cool. Let's not make me run back and forth.
Sorry, buddy. Oops.
Hey, Sathish. Yeah, thanks for that. I just had some questions for you in terms of my experience with the scalers, because I've used VPAs and HPAs in my personal cluster. So I was working on an application and I was testing the scalability features of all these APIs when they came out. And I had a memory leak in my code. So I'm not a good developer, but I'm just saying.
Yeah.
And I did not. So I had Grafana hooked up and I was looking at all the metrics, right?
Yeah.
And I didn't think it was coming from my code. And what happened was the pods kept scaling. And it was, based on my configuration. And I had an HPA at the time.
Yeah.
It just kept scaling.
Yeah.
And I ran it over the weekend and my costs weren't that great. So
you were running a managed instance of public?
Yeah, it was on AKS. So the question I had for you is now with KEDA in play as well. When the triggers depend on external sources, like you just mentioned about a database or RabbitMQ.
Yeah.
From a security perspective, let's say your database is compromised and there's a DDoS attack or something, there are 1,000 connections. I mean, 1,000 could be a small number here. So what impact, because of that correlation with your KEDA, would that have on your cluster? And from a security perspective, what guardrails would you recommend?
So you are trying to say there is a brute force attack, and then by which your number of requests increases, and then like whether scalar you mentioning, okay, you based on like if you see like 100 requests in my database, scale it.
So my question basically is, when can it turn from a boon that we have from a scaling perspective to a bane, where because of external factors there is that correlation? And it could.
But here it's just metrics, right? It's just doesn't know. It's not that smart enough to say whether it's a real user who's trying to connect to the database or it's a brute force attack.
But from your experience, any guardrails to avoid such situations?
No, it's it's just people are trying to make use of it more nowadays, but technically like problems can happen anywhere, right? It's not like only in this field or like this particular project. So yeah, like basically like you can protect the databases with authentication and then block with firewall or something like that. That's what I can do.
Can you link triggers at all? So like
Sorry?
if multiple triggers.
Yeah,
or
you
stuff-
can use
okay.
multiple triggers. That's our additional advantage. So it's not only database.
That might
You have
be-
like,
might be a way
yeah,
to solve your
you
problem
can
with that, right?
correlate with HTTP request or something like that. Like you can combine multiple triggers to like to make your scaling work.
Another question over here.
The KEDA autoscaler, can that trigger more than one namespace?
No, basically like you have to create the scaled object in a particular namespace, and then it's going to scale it on that particular resource, whatever the deployment. So it has like a deployment name and stuff. So you need to declare like what's the deployment name it should scale. You can have like multiple scaled objects, but it's not going to do cross namespace. So wherever you want the scaling to be done, you need to create the scaled object on that particular namespace.
So if I want to scale multiple applications within the cluster, how would you?
You have to create that many number of scaled objects. That's a KEDA resource, custom CID.
So I have to coordinate the triggering myself, right? Like I'll be like, I'll do this here, this here, this here. I can't. There's no mechanism.
Yeah, it's not that smart enough. Yeah, you need to like add like multiple triggers to like correlate and say, okay, these are my microservices. Let's say order, payment, cart, whatever, right? So and then you run in like a different namespaces. Then you need to manually create this scaled objects, but you need to correlate. Like you have your mind, right? Like how you, because observability is the main thing, right? So you need to have the observability in piece. You need to monitor your like last 6 months data, 3 months data. Like you need to understand how well your application is running, and then based on that you dictate the scaled objects.
Okay, we got one in the front.
Awesome talk, Sathish. So I got a quick question. Can KEDA actually monitor traffic coming into the cluster? So basically scale everything down to 0 and just have everything go to sleep. And then if traffic comes into the cluster, then wake everything up.
Yeah, that's what I'm saying. The HTTP add-on, it can do that. So it monitors the first. So there is something called a proxy layer in between interceptor. That's what I'm talking to one of the maintainer as well. So we are called HTTP. So basically there is an add-on called HTTP add-on. So what it does is basically like instead of sending traffic directly to your like basically the traffic comes from ingress, Kubernetes service, and then the pod, right? So what they're trying to do is they are mutating the Kubernetes service, trying to modify it to Kubernetes service to some other Kubernetes service selector. It go from ingress, it goes to the target ingress to your proxy service, and then from the proxy service, it go to the target part. So because they want to track the incoming request, so once that incoming request receives there, it knows like this guy received the traffic. So then when your replica is 0, where it's nothing running, you can go back. Like from there, it can start to whatever number. So that's like testing as well.
Hey, Sathish, great demo. And just to the gentleman to my right, I'll kind of come up to that question. So you mentioned you can scale to 0, right?
Yeah.
Would there be any use cases where you would not want to run KEDA? Like any app where you wouldn't want to have scale 0?
So KEDA is nothing, but it's behind the scene is just creating a HPA. So I will show you quickly. So even though like I just create a scaled object, you see it's get terminated. So behind the scene is just creating a HPA. It's not right. So I didn't create this HPA. I just created only the KEDA scaled object. But behind the scene it's HPA. They are trying to say, okay, based on this trigger, this is the metrics, and then this is the scaled object, this is the value. So it keeps monitoring, and then it mutates this part. So KEDA basically changes the HPA objects. Like instead of we manually creating the HPA says min and max, KEDA does it for you. It goes and mutates this scaled this HPA, by which it shows, okay, instead of running 10 replicas, just run 1 replica, whatever, like based on the desired value or whatever the metrics, right? So it changes this. When I was running 10, it will be 10, min replica will be 10. Right now I set it to star. So that's why it went and changed in the min replica to 1. If you see in the bottom stage, you will see the whole trace, like what happened in those 10. It modified the replica count and so on. So if you see here, it modified that HPA count and so on, I mean replica. So yeah, so that's about it, I think. One last thing, I just want to, thanks. Where is it? Just want to check. Okay, I just want like to hear the feedback about this presentation. So yeah, can you guys? Yeah, can you guys
I could put it in
scan
the email.
QR code if possible? Can you guys scan this QR code if possible, just for feedback?
Yeah, and reminder, there will be a CNCF specific survey that you'll get a ping at about 8:40 tonight. So appreciate if you fill that out. It helps for our next event in Q1. Any more questions for Sathish?
Yeah, thanks. Just one last slide. I think I just want to recap what we were talking. So is it? Maybe that's a good slide to show. Yeah. Is it play? Yeah, maybe you guys can take a picture of this. This has all the information. I just in a single slide, I just want to put it. So use the cluster autoscaler, and then cluster autoscaler has some warm period to scale up and down. So yeah, and then HPA, like it's basically uses based on the metrics, and then VPA is just either you can use VPA or HPA, you cannot use both together. And then KEDA is like you can connect to an external resource, use an external authentication mechanism to connect to your Kafka broker, whatever, you can pass the authentication and then connect to external resource and then get some metrics. And then based on that metrics, you can scale up the parts. And there are some pitfalls as well. You need to like make sure that the scaling policies doesn't conflict each other. So when you create scaled objects, and so like the one question you was asking, so when you have a dependency of multiple services, you need to make sure that doesn't doesn't have a conflict and doesn't override any of your settings or whatever. So yeah, basically general guidelines is like start monitoring whatever you are doing. Like observability is the key here. Start monitoring all your part resources, CPU metrics, and memory metrics. Yeah, use the resources wisely, and then yeah, go green.
All right, so we have a little scheduled break. I'm going to put a timer up for 15 minutes, get a drink, finish the pizza. We got a record number of slices for this event, so I'm hoping that we don't have to throw any out. Again, meet back here in 15 minutes. If you haven't signed in with me, make sure you do, because there will be a giveaway at the end. That's for that signed book.
Thanks, buddy. Hope I didn't something there.
All right, all right, all right. This is your 2-minute warning. We got 2 more talks for you. Please make your way back to your seats and get ready for Curtis. Right, 1-minute warning. Please make your way back to your seats. There will be a chance to talk after the show. All right, all right, all right. Wow, selfie without me? What is this, guys? All right, we're at 0. Bomb's going off. Can you say that in this office? Hey, you guys ready? You guys hanging out back here? Okay. Everyone can make their way back to their seats, please, and thank you. Yeah, that's all good. All right, make your way back. We got Curtis coming up talking about Falcoctl. I'm kind of curious to see how he says it. Take it away.
Okay. So yeah, this is a lightning talk. I put it in as a lightning talk, so it should be pretty quick. But this is about a tool called Falco CTL. I've never been able to say like the KubeCtl thing. I always say Falco CT or KubeCTL, which kind of makes no sense. Kube control. I mean, it's an old joke, but that's the idea. So Falco CTL is to Falco as KubeCTL is to K8s. You might say it another way. My name's Curtis. I work at Sysdig. So Sysdig is the sort of main steward of the open source project Falco. Falco is part of the CNCF. It's like a fully graduated project. A little while ago at one of these meetups, we sort of celebrated that graduation with a bunch of cupcakes. Maybe you remember that. So what is Falco, right? Like, is anybody here using Falco? So we've got 1, 2, 3, 4. Okay, not too bad. So like I said, Falco is an open source project, part of the CNCF. It's kind of the open source standard for threat detection, right? So if you go and you take the certified Kubernetes security course, you have to learn about Falco in order to get all the way through that course, right? That's part of the course. But what Falco is it's a pretty advanced technology, right? Like, so what we're doing is we're inserting code into the kernel, and I can talk a little bit about that. So there's either a kernel module or an eBPF probe or a universal eBPF. I swear I didn't turn it off. But the idea sort of is like Falco does one thing and does one thing very well. So Kubernetes is very similar, right? So Kubernetes, the open source project, their mission isn't necessarily to provide the best like enterprise Kubernetes or manage hundreds of Kubernetes clusters. That's typically what we'll use some sort of distribution for, right? Same idea with Falco. Falco is really designed to be like the best individual sensor. So it doesn't necessarily on its own manage like thousands of deployments of Falco, right? And this will start to make a little more sense as I get through this all. But here's the technology for Falco itself, right? So we've got the kernel module or the eBPF probe that goes into the kernel. We see every single system call, and then what Falco does is there's a rules engine. So you have rules, threat detection rules, and you compare those rules to the system calls that are occurring, and then you can like determine when there's an actual threat, right? So this is a security tool. If you want visibility into actually what's happening in your Kubernetes clusters or in your individual Linux virtual machines, this is the kind of thing that you need, right? And this is the kind of thing that often people don't deploy because we're all sort of, maybe not all of us, maybe just me, but like we tend to struggle with the technology, right? Like we might spend a lot of time just getting Kubernetes working, and then you got to do like Prometheus and Grafana, and you got to do this other stuff, and then 2 years from now we're going to do threat detection, right? But we should probably start doing it a little bit earlier because we need that visibility. But this is how it works. There's a couple of open source libraries that are part of it, but this is the main idea, right? So there's a kernel module that's in kernel space, and then there's an agent that's in user space. And that's where the rules piece comes in. And that's kind of what I'm going to talk about today is this rules piece, right? Because if you deploy Falco, but you don't have any rules, it doesn't do anything. So there are open source rules, of course. So if you go to like github.com, Falco security rules, you can see all of the different rules, kind of like what happens in the CNCF. There's mature rules, there's incubating rules, there's sandbox rules. I think if you add them all up, there's about 90 rules, right? But they're kind of generic, right? Like they're useful, but they're generic, and they don't necessarily meet the requirements for your specific organization. Like maybe you have something specific that you're looking for. These rules may not like meet all of your exact requirements. They're going to give you a good baseline, but to really use Falco effectively, you kind of have to write your own rules sometimes, right? And it's relatively straightforward to do them. This looks a little bit complicated, but it's just YAML, right? And all that really matters is what's in this red box where it's like if this happens and this happens, but not this, then fire an event, right? And so there's all kinds of ways that you can write that, but that's the basic idea. Is it's deterministic. It's if this happens and this happens, then fire an event. If the same thing happens, you're going to get another event, right? But you can write your own rules if you want to. Although I don't suggest trying to get ChatGPT to do it because it doesn't understand Falco rules, and it'll make up things that Falco doesn't do. So yeah. I guess my point here is that once you have that, like, so we kind of forgot a little bit about DevOps, right? Like DevOps, the whole idea of DevOps was supposed to be like people, process, tools, right? I think maybe DevOps didn't necessarily hit that mark, but my point here is like, we have the technology, right? Like you've got Falco, you can go and get it, you can go and use it, but really to make really good use of it, you need to be able to write your own rules. But then once you have those rules, you need to be able to distribute them. And this is where Falco CTL comes in, right? So I don't know, of those people that were using Falco, like, do you have more than 100 nodes or more than 1,000? I don't know, more than 100? Anybody? No? So Sysdig has customers that have, so maybe the scale doesn't apply to the people in this room directly, but Sysdig has customers, and you would be surprised at how many companies out there are running 25,000, 30,000 virtual machines. Like there's more than one. We have a customer that has 300,000 virtual machines, right? There's a lot of customers that have these companies like you start out, well, we're just going to deploy one virtual machine, and then you get really successful, and all of a sudden you've got like 30,000 virtual machines, right? But you need to do threat detection on all of them, right? Because you don't want to get like ransomware across every single virtual machine that you have. So you need to deploy Falco, but then you need to distribute these rules, right? So you might have, maybe not people in this room, but there are companies in this world that have tens of thousands of virtual machines that have Falco on them, and they need to deploy the rules to them. So that's where Falco CTL comes in, right? As well, Falco not only has rules, but it also has a plugin model. So this was kind of a recent advancement where you can write a custom plugin or use the plugins that exist already. So there's a bunch of existing plugins. So I kept talking about kernel modules or system calls. We don't only look at system calls, we can also look at almost any streaming log file, right? And it's actually relatively straightforward, but like, for example, Okta audit logs or Kate's audit logs or GKE audit logs, right? Like we can actually look at any audit log. But if you allow the ability for people to make plugins, guess what they do? They go and make plugins. So how do you distribute them, right? So now we've got two different kinds of artifacts. We've got Falco rules, and then we've also got plugins. So how do we distribute those things across potentially thousands of nodes? How do we get them installed? How do we do all that work, right? So that's where Falco CTL came from. So using Falco CTL, so this is from a blog post, I didn't make this diagram, but you can basically kind of GitOps your Falco artifacts, right? So you can distribute them in an OCI image if you want. So OCI is like the, what is it, the open container, I can't remember exactly, but it's like, it's the specification for container images. And so this might be maybe the most interesting thing to people in this room is you don't only have to distribute container images with OCI images, you can actually distribute almost anything, any file if you want to. You could use that same specification to distribute files and version them, and it doesn't have to be a container image. You can put almost anything into an OCI image, right? And so that's exactly what we do with Falco and Falco CTL is we can build a container image that contains the rules, push that into a registry, and then use Falco CTL in every one of these nodes to pull that information down, right? But obviously, with that in mind, you could do the same thing you do when you build Docker images or container images in your GitOps pipelines. You can do the same thing, right? So let's do a quick demo. And I can actually do this one with one hand. Just watch me type here. I'm just gonna, yeah, okay, sorry, I should tell what we're doing too. I'm just using ASCII Cinema to play this, but okay. So what I'm doing is I'm setting a variable for the OCI artifact version. So basically I'm changing, you know, I've written a new rule and I'm gonna deploy it, right? So this is how I do that. So I say I'm gonna do deploy this new version. So what I'm doing here is I installed Falco CTL. Falco CTL also has the concept of indexes, which maybe I'll talk about if we have time. But basically, there's a default index. So that's what I did here is I added that index, this one called Falco Security. That gives you a bunch of automatic artifacts that the open source project provides, which I think I'm going to list here. Yeah. So here's a list of all the default artifacts, right? So you can see we've got different plugins and rules files and things like that, fun stuff. And now what I'm going to do is take a look at the Falco CTL configuration. So here's the Falco CTL configuration. You can see some repositories. You can see this initial index, right? Then I'm doing this all in the same node, but I'm going to create a systemd service for Falco CTL. Then I'm going to log into the registry with Falco CTL, right? So that's how we distribute the image. So I've logged into key.io. Here I'm showing the current version, right? So the current version of the files is 1.06, but you saw at the beginning that I was going to update it with 1.07. So now I'm going to push the rules to this registry. So I'm like pushing an OCI image that only contains that rules file. Then I'm going to pull it again down to the same node just to sort of validate that it got there. But you can see that this is like version 107, right? So I'm pulling it back down with Falco CTL, sort of like Docker pull an image. Then I'm going to update this file, and I'm going to tell Falco CTL to next time it starts or in 5 minits. So this is kind of like a cron job based idea. It says every 5 minutes, check the versions on Falco in Falco, then also go and check if there's a new version of this image, or this, in this case, this specific image, right? And then I'm going to pretend that I waited 5 minutes and just restart Falco. So it's going to go and grab that new container image that has the new rules file. And then I'm going to just wait for it to actually get downloaded. And then at the end here, we can see that like I'm catting the custom rules that I created, and we've got version 7. And so I don't know if that looked super interesting, but the whole idea is that we can update the images, and then you could have hundreds or thousands of Falco nodes go and just automatically grab that every 5 minutes, right? Every 5 minutes, they're going to check and see if there's a new version. They can go and pull that information down, right? And so this is the basic idea, right? Thousands of nodes, Falco CTL is going to pull from that OCI registry, just like we kind of do with container images. But the main point, I guess, too, is that like the people part is the really hard. Like writing Falco is pretty challenging. Like it's highly technical. You need like people with a lot of experience to write modules. But once you have that technology, now the hard part is like writing and updating rules, right? So this is a lot of work. So you can also consume rules from Sysdig if you want to as well, right? So instead of writing your own rules, you can get them from Sysdig. We have something that we announced at KubeCon called Falco Feeds, where you can use our rules that are built by our threat research team instead of having to write your own. But yeah, that's kind of it. I put this, what code there is, up on GitHub if you want to go and take a look. I also, let me pull this out of the way, showed a little bit in there that I didn't do today, just in time, like what an index file looks like and how you can go and add an index file and search for artifacts and that kind of fun stuff. But I don't know if anybody has any questions, but that's all I had. But I have a water bottle to give away for questions.
I do. Well, first question, do you have any hints for the CKS Sysdig questions? What should we know?
I probably don't, because I took the CKS 4 years ago and then I didn't update it. So I haven't looked at it for a while, but we actually, yeah, we do have a webinar actually, I think Sysdig does on this.
I wanted to hint to the question.
Yeah. But yeah, sorry, I haven't seen it, so I don't know.
I don't want you to have your hand up. All right, start over here.
So I had a question regarding the indexes, which is basically, oh, shoot. Okay, thank you.
Yeah, first.
Which is basically a collection of artifacts, right? So I was wondering if these artifacts, we could have it, say, in an enterprise internally within some form of a network mirror. Because I saw in your manifest, you had falcosecurity.github.io/index.yaml. If we could have an internal mirror for, say, enterprises and we don't want to go outside the network.
Yeah, absolutely. Yeah. Yeah. Okay. It's all open. So you could absolutely pull them in and change the index to point to those. Absolutely. Yeah.
Okay. Thanks.
Yeah. I've got some t-shirts here too. I don't have any larges.
You have a t-shirt gun with that thing?
Yeah. Everybody, if anybody's got another question.
Large?
I don't have any larges. I have extra large, medium, and small.
XL is great.
Okay, I only have one. I think I have one extra large.
Thanks for the talk, Curtis. So ultimately, whether you're using OCI artifacts or your own inline YAML rules, does the Falco CTL compile everything into a single custom rules.yaml at the end of the cycle?
No, you can have as many rules files as you want. Yeah.
But the ultimate output of all the artifacts you've told it to use, it gets compiled into a YAML file?
Yeah, for like the actual agent piece?
Yeah, for how it gets used by the Falco agent.
Yeah, yeah, it would be one piece. Yeah, one big thing, yeah. But you could define them individual file, yeah. And we don't have to do too many questions, and I'll give away the other t-shirts too, yeah.
Awesome talk. I'm not really familiar with Falco, but I'm kind of curious, when you're pushing that distribution of all the OCI images down to all of the Falco agents, what does Falco do when it does actually detect a threat? And let's say I have incorrectly written my rules and it's actually not a threat. Does it take all of the processes offline and actually block something that I might need, or does it just alert when it finds a potential threat?
When it finds a threat, like when one of the yeah, there's a whole actually. So there's something called Talon, I think. So you can send the alerts from Falco to an open source centralized platform that will take them in from all of the nodes. Yeah, it's another project. I always blank on the name, but there is another project. If that's what you mean, like where do the alerts go, right? Yeah. So you can actually send them anywhere you want, but there is an open source project that deals with taking them in. Yeah. I'd have to check and see. I don't know. Yeah.
But there's no like enforcement on it.
Yeah. Curtis, great talk.
Yeah.
Yeah. A meeting for this gentleman to my right. But yeah, just my question is more about the rules itself. So once you have the rules centralized, do you, and I guess maybe I don't know too much about Falco, but do you use this like container registry to push the rules and then those rules get updated to the agent? Or is it mostly like the agents that make sure that they're always up to date?
Yeah, so Falcoctl is a completely separate tool, if I'm understanding your question. So you would write the rules.
Yes.
Use Falcoctl to push them to a repository.
Correct.
Then another Falcoctl would download that image, unpack the rules for the agent running on that host. But the agent is a completely separate process.
Got you. And then like keeping that sync between the agent and the rules, Falcoctl doesn't do that.
Yeah, that's its point. Yeah, yeah. Mm.
That's sorry?
That's its job.
That's its job. Okay,
Yeah,
so
yeah.
keeping that sync.
Yeah.
Okay, awesome, cool. Thank you.
Yeah.
Very helpful.
Questions? T-shirts. Hands go up.
Hi. So Falco runs on the nodes, right? Like if it's
Yeah.
a AKS cluster, it runs on the node itself. Wondering what if you're writing a custom rule, and is there any mechanism that like once it detects a threat, is it going to just fire an event, or is it going to block that specific call?
No, it is non-blocking. Yeah,
Oh.
that's part of what I was talking about, the performance piece. It's completely non-blocking. Yeah, so it doesn't block on any of the system calls. Yeah.
So it does fire an event. Somebody needs to monitor and act upon it, right?
Sorry, I didn't catch. Like it does fire the event. The event, like everything goes to a ring buffer. That was way back here at the beginning. This ring buffer, right? So all the system calls go into this ring buffer. So that's why it's non-blocking. And then the agent can look at what's in the ring buffer, right?
Okay. Is there any tool that threat monitoring team or somebody can monitor, like, and act upon it?
Sorry, I'm not quite. Oh, like, are you saying like who's watching the watcher?
So what's the next step? Like, who's going to take act on it? Oh, by system. Oh, okay.
Yeah, that's the right question.
So after you get an event, what do you do? Yeah. Yeah. So there's an automation. I think I might have been mixing up. My colleague in Montreal did a talk on this, I think. Yeah, so I was saying Falcon or Talon, but there's a whole open source project called Talon, which is a response engine. So you're kind of talking about auto remediation, right? Like, so you get a threat detection event. How do you know when you got that event, and then can you automate something to happen after that event occurs? That's the Talon piece. Yeah. Yeah, and he, my colleague Murat in Montreal, he did a talk on using Ansible. What's the super? Event-driven Ansible. Yeah. Great questions.
There's one here, right? We got time for two more.
Hello, great talk. So I had a question. Sorry.
No worries. Yeah.
Just thinking here. So you said about. It's kind of weird to get the echo.
Yeah.
Not used to. So you said about doing pooling to get the rules. Is there a way to react to events instead of pooling? Like react to events to fetch the new rules from the
Oh,
repo
yeah.
instead of
I hear what you're
having to
saying.
pull from time to time?
I'd have to take a look. I don't think so. I think it's all based on like a pull concept. I mean, you could potentially wire up anything you wanted to do that potentially, like stick a message in Redis and have something have other process watch. But I'll check on that. But I think it's basically pull. Yeah.
Okay. Thank you so much.
If a poll fails, do you get notified?
If Falco fails?
Yeah, like the poll. Like if Falcoctl, like going and pulling the image, if that fails, do you get notified?
I'd have to check and see what you could do around that. Yeah.
All right, last one.
Hi, I'm pretty new to this, so forgive me if the question is
No problem.
So you mentioned we have Falcoctl compared to kubectl, right? When the rules get very large, because you mentioned the client manages like 30,000 VMs, right? When they get very large, you have to write large amount of rules. In Kubernetes, we have Helm to simplify how we write a lot of configuration files. Do we have something similar in Falco?
So the number of virtual machines you have wouldn't cause you to have more rules, number one, right? Like, so if you had 10 rules that you had written and you had 10 virtual machines, you'd still have 10 rules. If you had 1 million virtual machines, you'd still have 10 rules. So that doesn't really matter. But no, there's no like, so, so like I said, Falcoctl is to Falco as kubectl is to K8s, but it's not like kubectl. It's not really, right? It's not a declarative tool. It's more like it's almost more like Docker pull than it is kubectl, right? So it's not the greatest title, but I couldn't stop myself from using it. So it's like Falcoctl helps to manage Falco, like kubectl helps to manage K8s. But so there's no real need for a Helm package manager because Falcoctl is the package manager, right? Yeah.
Awesome. Thank you, Curtis.
Yeah. Thank you all. Yeah, great.
We got our last talk of the day. Rajith, you ready?
Thank you. All right, thank you. Happy to be a part of the holiday edition, and thanks to the organizers for giving me an opportunity to come talk to you guys. So since this is the last one and everybody's tired, I try to keep it a little bit lighthearted. I want to talk a little bit about Kubernetes costs and how to control them. I am Rajith, founder and CTO for Andoli. I lurk around these open source projects, Pixie and OpenCast these days, and pretty interested in OTel and eBPF. Right now, let's get down to business. So we'll first talk about cost visibility and different aspects of that. We'll look at the open source solutions. I'll talk about OpenCast and using VPA for right sizing, and then we'll take some questions. Yeah, good? All right, so I will start with a story. Oh, took some time, right? Okay, so 2 days ago, I was working with a couple of folks from my organization. We were evaluating some new experiments that we're doing using machine learning for our product. And so one of the groups, the ML engineer and the developer was like, so now to run this, this LLM has 8 billion parameters to get a sub-millisecond response. We got to use this particular VM. It's like I think it was called NC, it's an NC3 series on Azure, AKS, where we run a dev on Azure. I looked at the cost, $2,200 a month. And they were like, oh, we need one for dev at least. And then, of course, in prod, you need at least 2 nodes. So when you dig a little bit deeper, it's an experimental feature that we're rolling. So it's not like it's going to be utilized heavily. So there's a lot of idle time. And then what else? It's, and also we don't need a sub-millisecond response, right? If it takes a couple of seconds or up to a minute, it was fine. So the problem is and we've seen this quite a bit over and over, developers tend to, they love giving sometimes a little bit more. They are on the side of caution. So over-provisioned workloads is a big issue. And this is something that we've seen with our product. This is something that we've seen during our consulting days. And I've been there too. Just how much memory do you need? Yeah, I think it'll be okay with, half a gig, but let's give a 1 gig just to be on the safe side, right? Not just the data that we've seen with our product, it seems like the industry reports agree. So this is actually from Sysdig. Obviously they see a lot of containers out there. I've seen a similar report from Datadog. And CPU, mind you, is an expensive resource. And that's the one that's probably least used. I don't really agree much with the limits on CPU. That's a different conversation, but we can chat about that when we talk about right sizing. But most places that we work with, most customers we worked with, there was always some opportunity to save cost. And I know we're preaching, but we also saved 15, 20% when we started using open cost. So that's when we realized, oh, this is good. And we incorporated it into our product. But this is getting worse. There's a lot of companies jumping onto AI. GPUs are being used, barely used, and that's expensive. I can't even say much, but it was a government customer, but taxpayer money. Yeah, it's 4 GPUs, 8% utilization. So it's paying attention is important, because you can optimize what you can't see, right? So that's one of the big problems. And then we've seen some other things as well. It's a little bit of a lag for some reason, I don't know. People also go and do aggressive, limit setting, and there's always a trade-off between cost and performance. So when you're trying to cost optimize, something to keep in mind, for certain workloads, sometimes having a little bit extra makes all the difference between, missing a transaction versus making it, right? So that's something to keep in mind. Right. Let's dig a little bit more deeper into these things and talk about some of the other stuff. What's this? Okay, so recently someone asked, hey, how do I figure out how much does my sidecar containers cost? So this, we were working with another company that has a product based on Istio, and one of their customers had a massive footprint, and their sidecar container cost was huge. And the outcome was that, okay, let's switch to ambient mode. So we get rid of the sidecar. So knowing these things, you need that kind of visibility. Like I said, you can't optimize what you can't see. Right. Let's see this one. If you want to, figure out node sizing. Okay, so by the way, there's Carpenter that can do some of this stuff for you automatically. I highly recommend having a look at it. Both AWS and Azure has first-class support for it. But even when you do use Carpenter, and you can tune Carpenter by talking about giving different node pools or other node sizes, you need to have a baseline to understand which one is better, right? So some folks are like, oh, maybe we'll have a less number of larger nodes versus a higher number of smaller nodes. Should we use memory optimized nodes? Should we use CPU optimized nodes? How are you going to make the decision without getting into the, figuring out the visibility, right? So that's important. And, this one. And we actually heard a personal horror story today. Sorry to point you out, but you talked about the cost increase, right? Yeah, sorry, I didn't mean to name and shame you, but this is something, so let me answer this. You asked a good question about, hey, how do I limit this, right? So just taking aside, there's a couple of things you can do. Most cloud vendors, you can limit the max number of nodes from an auto-scaling perspective. So that's one. There's also budgets and alerts that you can set. But on the cluster itself, you could use OPA or Kivano to add policies to kind of limit the number of replicas to go beyond a certain point. Yeah, and then you can do cost alerts and stuff like that to keep track. So one of the customers that we work with is another story, and he said before we told me the story, this is not from our department, by the way, it's from the other department. Yeah, right. I think it's with them, right? 1 month they had $150,000 increase, and they only knew when the bill came. So it was a fun conversation with their management, from what I heard. But more importantly, when costs go up or down, it's good to understand why it happened, right? So I kind of wear 2 hats. I'm partly on the development side, but I also have to worry about cost and budget and stuff like that. So, I mean, my platform team, they're not dogs, but that was the look that I got the first time we asked, so why did it increase? People didn't know what, we knew there was an increase, but we didn't know what caused it, right? So that's digging into that is very important, right? Right. Okay. So final one, and this I've seen not just in larger organizations, but in smaller organizations as well. People set up workloads, people set up clusters, environments, and then now with platform engineering, the new thing is, with the click of a button, you get to do your own cluster. You can provision this, you can provision that, but that comes at a cost because sometimes people forget to take it down, right? So you need some sort of accountability, right? So people need to, either there should be some sort of idle workload detection thing, or people need to take responsibility. So easier said than done, yes. And my favorite one, this is, and we see this again with larger customers. Sometimes it's an argument between the ops team, the platform team, and the engineering team. Like, yeah, but you know what? Because the developers are also scared. Like, if I reduce this, my God, what if something goes down in prod? Now it's on my head. So like, I don't care. So what most IT organizations do, especially if we look at the large enterprises, there's a chargeback model, and if you want to use it, sure, you get the bill. I mean, it's very similar. Like when my daughter was 15, we bought her a phone. Next year, she's like, I need the next iPhone. And, I think between 15 and I guess 19 or 18, there was 2-3 phones. And then she went to university. We gave her an allowance and it said, you can pay for your phone. So 3 years later, she's in like third year now. I asked, so why are you still using the same phone? I don't have the money anymore. Because that's the same thing with chargeback. Because the moment you put the onus on the team budget, the department budget, then that's another implicit way of controlling costs, because now they have to worry about it. We have to pay for it. So chargeback matters. Right now, so I talked about a bunch of stuff. Let's talk about some open source solutions that can start to help some visibility into this, right? So the first one is OpenCost. How many of you have heard about OpenCost? All right, very good, very good. Okay, good. So the KubeCost team, they donated this to OpenCost, and now we are part of that project. There's a couple other vendors that are supporting it as well. There's kind of like fundamentally 2 things, 2 building blocks that that you can use when you're building any kind of cost functionality on top, right? If you look at the APIs, and you can look at the UI, I'll show it in a bit. It's not very fancy, but underneath, that cost model is pretty powerful. You can build everything that I talked about with a little bit of elbow grease. You can build all those functionality that I talked about. Cost alerts, chargeback, right? Some help for right sizing, cost visibility on top of OpenCost. So there are 2 concepts, 2 fundamental concepts. One is called resource efficiency, and the other one is called resource cost. So I'll explain what the efficiency is. Very simply, if I have a pod and I'm requesting X amount of CPU, memory, and GPU, that's your request. And when it starts, when the workload runs, it uses a certain amount of CPU, memory, and GPU, if it is going to use GPU. So the difference between the usage and the request, that's utilized in the calculation. So if you're using half of it, you're kind of like 50% efficient. There's a slight, I mean, it's weighted a little bit more towards, it's a weighted calculation, weighted more towards CPU because CPU is a more expensive resource. So, more often than not, just by running OpenCast, you will see how efficient your workloads are. And the difference between your usage and your request is your opportunity to save cost. Every little workload, you add it step by step. And if you multiply that by the number of workloads you have, the number of clusters you have, that can be significant. That can be significant. And sometimes if you will see that the efficiency is more than 100%, so don't worry, more than 100%, it's not an error. If your workload actually ends up using more than the requests and up to the limits, then you will see better utilization. And that might be a hint for you to think like, maybe I could up the request a little bit, maybe, something to look at. The resource cost is what it does is using the request or the usage, whichever is higher, it'll use the pricing sheet from the cloud vendors and it'll attach a cost. So now you also start to see not just the efficiency, but the dollar value of what each workload costs. So I'll show you, let me go here. I'm not really good with this one hand stuff, but I'm handicapped even on a desk with a mouse. So here you go. So like I said, don't be discouraged by this UI. You see the breakdown over there. It'll take a little bit of time, so because of that, I'll just show. You can actually, let me see. See the different kinds of stuff that you can see. So that underlying model can actually give you that breakdown by these different levels of aggregation. It'll go all the way down to container. You see, container level. Yeah. And then if you look at here, you see there's a cost for CPU, memory, persistence, volume. There should be one for network too. We are currently working on a patch upstream to calculate network costs. So egress, zone, and region, intra-region. I'm not sure, like, has anybody been hit with a massive egress cost? Yes, okay, so I'll talk to you. Yes, so I did a talk in Vancouver about, EKS best practices, and a few people came up with some horror stories. Egress costs can be significant. The best practices normally for clusters these days is you put it on across 3 availability zones. And if you have very chatty workloads, and they are gonna now, like a Kafka broker, because normally the you put each broker, right, on each availability zone. So it's very highly available, but there could be a massive cost in the zone cost. And, most cloud vendors say it's a gigabyte, 1 cent, yes. Yeah, 1 cent, something like that. So per gigabyte, but it's actually one for going in and one for going out and one for going in. So for each, the gigabyte actually costs 2 cents, but the pricing sheet says 1. So network cost can be significant for certain customers. So that's something to keep an eye on. And some people are completely oblivious because you get a big egress cost or a intra-zone cost. Now you don't know which workloads are actually causing this, right? So that's something to pay attention if that's something that's affecting your cloud cost. And then we are beginning to see that folks who use like a lot of data science workloads, and they're using these specialized disks and stuff like that. They're seeing high cost associated with SSD disks and stuff like that. And so it's a good way to figure out, and we don't, unfortunately, the free, we are not running any GPU workloads for the demo, but you can see GPU as well. It's not here in the UI, but in the underlying cost model, it's there, right? So using this model, you can, and there's a set of APIs that you can use. There's a Parquet exporter, and there's also a plugin architecture. So one of the open source plugin somebody contributed. The most popular one is the Datadog plugin. No shit, right? It's expensive, right? So someone, yeah, so they contributed it. The another one is for OpenAI, yes, and then and you know there's different external. There's a cloud external cost one as well. So it has an extensible sort of like a plugin architecture, and like I said, you know, a nice set of APIs. And I know personally some very large organizations that have built sophisticated stuff just on OpenCast. Instead of choosing a vendor, they have built very elaborate cost modeling stuff just based on that. They're using the Parquet exporter or just using the APIs and grabbing that stuff and showing stuff like that. So yeah, and then yeah, we ended up building some stuff on that. So it's a pretty cool project. There is some support from Azure as well. So we are working together with them on GPU costing and stuff like that. If you're using AKS, there is a cost add-on that's actually powered by OpenCast. I think AWS has something similar as well. All right, so that's just one. Let me go back to this. Right, it's only a couple more slides. And oops. Yeah, there you go. Yeah, and generally, I think I'll leave you with this kind of like one thing on the cluster stuff. Generally, what you see is when you start to look into OpenCast, you will start to see the idle cost and the workload cost. And by my personal experience is that, and I could be wrong, you know, you should probably leave about 10 to 20% idle, if depending on the type of workload you're running. But if you're seeing more than that, that means there's ample opportunity for cost optimization, and you know, look at Carpenter or other things to kind of, you know, do some cost optimization. Yep. And then Sathish talked about VPA in a different context. But VPA, you can actually use this to get right sizing recommendations. You can run VPA with update off. What it does is it'll still create the object. Yeah, okay. And what it does is it actually gives you some sizing stuff. Oh, takes a while, but yes. And you can use this to get some hints about right sizing your workloads, right? And generally, my recommendation is it's using data on Prometheus about 7 days. But this works for some type of workloads. May not work for other types of workloads that has very what do you call very high seasonality in their workloads, right? Very variable. But otherwise, good place to start. That can help you right size your workloads by looking at the recommendations that the VPA is providing. And along with the OpenCast, you can solve some of those things. I think we are probably at the end. I'll take some questions. So, you know, just a summary of what I talked about. You can optimize what you can see. So get some, you know, like, you know, try out OpenCast if you haven't. It's you know, obviously a free Helm chart installation. Workload optimization, I just talked about it. Generally, variable problem, but at least it's a good place to start with VPA. Over-provision workloads and idle workloads are very common from what we have seen in the last couple of years. Cost alerts, and so you know, you don't run over on personal projects or on the company. Sorry, and then a chargeback is important. Yeah, I mean that's about it. I'll take some questions. I think I have 2-3 minutes, so it's a lot of questions. Because we don't have a lot of time, I'll skip some of these other stuff and go. Yes, you can follow me on Twitter. We're going to do some more talks on this. Who has questions?
Hi, I have a question.
Yes.
So I have a couple. So I never used OpenCast before, but how do you tie specific resources to a team? Like I know GCP has like concept of like tags that are associated with resources. So like, you know, you want to monitor and make sure like what the team costs are, you say, right? Like if some teams are just abusing resources or not, right? So in terms of OpenCast, like how do you tie them to each team?
Okay, a great question. The short answer, sir, that is what usually the vendors end up doing. So, but you can build it yourself. What you want to do is you grab the data from OpenCast and you can use labels. So I would say that's a great way to do. A lot of chargeback is usually done on a per namespace basis or label basis. There are good reasons for it. I can chat with you afterwards why the pros and cons for those things. So you can, if you have the labels and you use the open cost data, there are identifiers that you can tie in your labels into that. Now you can use the labels to slice and dice and aggregate based on those.
I see. So also as an experience of running cloud monitoring stuff, cloud monitoring can be very expensive. I'm guessing open cost like continuously pull APIs just to monitor, like I guess for example GCP APIs, country monitoring. GCP APIs are not cheap.
The cost, you're asking about cost of running open cost?
Yeah.
So it actually gets the pricing sheet. There is no real the cost is negligible from that, but it does consume some CPU and memory to run the open cost itself, right? But there is the cost of running it is not that high in my opinion.
Oh, like it's not continuously pulling GCP API to get all the resources. Like
no,
compute instance has their own NLP API, and
No. It's just download. So you're talking from a pricing perspective? No. And it uses Prometheus to actually keep track of the resource usage. So there is no extra cost from that perspective. Yes.
Right. Sorry, just two more questions. So the other one is companies have like a multi-year contract with GCP or the cloud vendors, and they have different pricing models. So like I guess is there a way to configure those?
Yes.
Okay.
Turns is yes.
And then there are cases where, like for example, there's a Black Friday and things like that, where you need to have so I've ran into multiple cases where GCP runs out of resources or like runs out of computing systems, and then cluster cannot scale. Like especially during like Black Friday or like some event days, right? So oftentimes you have to like predictively scale up and waste resources in order to like handle those. Is there any smart way to deal with this kind of situation here?
Yes, there is a bit of a long answer, and there was a good talk during KubeCon as well. We've done some research, like significant research on that. I can chat with you after. So predictive scaling or ahead of time scheduling is something that will that you will start to see more and more often now from folks who are doing it. Yeah.
Okay. I'm done. Thank you.
You're welcome.
Thank you. And event-driven, Kubernetes event-driven autoscaler.
What's that?
You can set up rules proactively for certain days, right? And certain time that you things are coming in. And the talk earlier will cover that.
Hi, I think you just briefly mentioned it. So does it use Prometheus to figure out the over and underutilization? And how does it correlate the raw pods, deployments, et cetera, to which Prometheus metrics to pull for those?
So yeah, a good question. It'll use Kubestack metrics, so it knows some of the usage and stuff. One thing I would caution is if you have a very, very large cluster, open cluster a little bit. If that's the case, let me know. So there are some certain limitations as well. It'll put a lot of strain on your Prometheus instance, yes.
Yeah, you have briefly mentioned to monitor networking costs, but given how difficult or how complicated like Kubernetes networking is, like with CNI service mesh, and service mesh, like ambient mesh, how do you have any like ideas or tools in mind that can be used to like monitor cost on these?
On the network one?
Yeah.
So the network cost, like I said, OpenCost doesn't handle it yet. Or at least that part wasn't donated to OpenCost. We are currently collaborating with some other folks to contribute that patch. It'll be based on eBPF.
eBPF based. Okay, thank you.
Any more questions? Okay, we got a few. Coming to the front for the next one.
Sorry, did you say OpenCost right now support Azure and AWS?
What's that?
Does it support all three clouds?
Yes, currently, yes. And
Okay.
I believe there could be something for Oracle Cloud too. I've never tried it myself, but I've tried it on all three major cloud vendors and it works.
Okay, and how fast is it updated if the cloud providers change their price?
So there is I don't know the exact specifics of the exact duration and how it does, but it can, it does poll periodically for the pricing sheet. The exact duration, I'm not sure. And then there's also other nuances to this, right? So this may or may not be a problem depending on the size of your spend. So for example, in spot instances, the price you may see at the time you try to grab it and the price you get when it's actually used is different. So there is a process called reconciliation where you actually reconcile the using, so in AWS there's Kerr, so there's some similar stuff available on Google and Azure. You have to do that reconciliation, do that this kind of adjustments. If you have a significant cloud bill, this can be a significant portion, right? OpenCost doesn't do that, and that's a process that you have to build yourself. Yes.
Okay, thanks.
Yes.
Thanks, Rajith. That was a great presentation. So I think you alluded to this at the beginning of the talk of requests versus limits. So I work with an engineer who's very similar in your opinion. He doesn't like limits. When we go to our customers, what is the recommendation to tell them like stay away from limits, leads to pod exhaustion, but rather use requests? And can you answer the question maybe in the context of cost, like optimization?
Right. So when you talk question limits, so we'll just talk about limits per se. So you have memory and CPU. So CPU is a compressible resource. Memory is an uncompressible resource, right? So if you have 100 gigabytes, you can only go up to 100 gigabytes. But for CPU, you can oversubscribe, right? So when you oversubscribe, it'll get throttled. So giving arbitrary limits on CPUs, there's several schools of thoughts on this. So giving, like I personally don't want to give limits on CPU, but memory, I'm a big believer because people will be abused. So limits on memory is okay. And then there is also a school of thought about not giving requests for CPU as well, because if an application is underutilized, but there are other CPU hungry resources, now you can use it because it's already allocated to something else, right? So when it comes to limits and so there's other aspects to think, right? So if you look at larger organizations, to prevent abuse and create a fair model, they will end up putting quotas, right, into namespaces. So that that then has other implications there, right? So in general, though, I think for most people it's good to set limits, at least to begin with. CPU is where I would probably think about the limits, but memory, I think, like if you don't, there's more opportunity for abuse and errors and other things, right? Like people just can step on other applications if you don't enforce that. Yeah.
Right. Awesome. Thank you.
No worries. You're welcome. Good to wrap up.
Yeah, so I've used OpenCost before. Great product, thank you. I just was wondering because I was thinking of long-term retention of my metrics and was thinking of using Thanos. And I'm not sure if OpenCost supports Prometheus-supported data stores like Thanos, because you did mention we can use Prometheus as one of the sources, right? Does it support like Mimir or Thanos for long-term retention?
You can do that yourself, for sure. But that's something that we are doing because of certain limitations and stuff like that. You can absolutely do that. But you would have to, just like I said, just rejig a couple of things here and there, and you can absolutely do that. It's not a problem. Yes.
Okay.
You can also look at an alternative source for Prometheus as well. But again, I can't name the cloud vendor, but that's the path they took to store OpenCost data for different reasons. Yes. So you can take the source code and do what you want. Yeah.
So with that in mind, because I know one limitation I faced was not a multi-environment setup. I could only deploy one OpenCost instance with one Prometheus server in one cluster. Is that possible if I have a centralized environment and then tap in where I have multiple clusters sending metrics to that central environment running Prometheus and have only one OpenCost instance in one cluster that can tap into that centralized environment?
So you can run one OpenCost to look at everything. That again is where the vendors make their money. It's a
Oh,
simple answer,
okay.
yes.
Got it.
If you look at most of the open source projects, they are scoped to a single cluster, and the vendor product is what gives the multi-cluster.
Got it.
Right? Yes.
That's fair.
Yeah.
Thank you.
But it can be done in the sense that you can scrape those, and that's where the retention and the multi-cluster view comes in. Yes. Good. Going once.
Good. Awesome. Thank you.
Thank you.
Jeff.
Thanks a lot.
All right. Did this whole one-hand thing. Okay. Wrapping it off. Kubernetes up and running, signed by Kelsey Hightower. Ooh, yeah. I heard some oohs. Who was that? Okay. Smooth. So what I've done is everybody who signed up, I took your names. You had to check in with me, and then I put you into a random generator. And we're going one spin. Drum roll, please. Devin. Do you leave? Stephen K, that's you. Some final things, like I said, survey is going to be going out. I'm going to wrap it up with all the content that we came over, all the slides and everything like that. We're going to aim for a Q1 meetup. I'm assuming late February, probably March-ish. Make sure to get your talks in. We're going to start planning and pulling talks in January. So if you have anything you want to talk about, anything CNCF related, there will be a link in the follow-up email to the speaker call link. And appreciate all your help. Thanks again for Ada for hosting us. Thanks to Doppler for sponsoring and the pizza. And thanks you guys for coming out. Really appreciate it. Have a good holidays, and we'll see you in the new year.